Okay, wonderful. So now that we know why firms might have market power, let's think about what they're going to do with that market power. In other words, if my goal is to maximize my profits, and I have the ability to set my price, right? I face a downward sloping demand curve. How should I set my price in order to maximize my profits? So there's a couple things I want to be clear about here. So one thing is, I'm going to assume I'm a firm that has a demand for my product that's downward sloping, right? I don't have a demand that's perfectly horizontal. I can sell as much or as little as I want at some price. I can sell more units at low prices than I can at high prices. I'm also going to assume, for now, that I have to sell my product at the same price to all of my customers. In other words, even though there are some people who would pay a lot and some people who would only pay a little, I have to pick one price and then sell as much as I can at that given price. And the reason I'm going to assume that, we'll talk about this more in next lecture, the reason I'm going to assume that is because if I wanted to charge a different price to each of my customers, I'd have to know who the people are who are willing to pay the most, and I'd have to have some way to stop the people I sell to at a cheap price from just putting their stuff up on eBay and getting, selling it themselves to the people who would be willing to pay a higher price. Okay, right, so this is the basic problem I'm going to try to solve. I'm going to try to decide the price and quantity, assuming same price for everyone. Great. To make this concrete, right, we're really talking about any firm with market power, but let's pick a particular firm. Let's say that I'm the proud inventor of the mop socks, right? Mop socks, the socks that mops while you walks. It's a brilliant invention where with the use of, gripping, rubberized technology, I've produced a comfortable sock that as you shuffle around your apartment, picks up spare debris and results in a sparkling clean, beautiful hardwood floor without any extra work on your part. It's a really wonderful invention, right? And I'm going to assume there's some people who are desperate for these things, right, have been waiting all their lives, willing to pay very, very high prices for just a little taste of mop sock. There's other people who, of course, recognize the brilliance of the idea, right, but are willing to pay a much, much lower price, right? They're basically willing to pay the price of a normal sock or a normal mop. They're not going to be willing to pay 2 or 3 times the price to get my wonderful product. So I've got a downward sloping demand curve, right, as we've laid out. Otherwise, though, I'm going to have cost curves that look just like the firms we've been talking about all along, right? So I'll have some marginal cost, where I'm going to have some marginal cost that is upward sloping, just like our marginal cost in the past, maybe downward sloping at the beginning. If I wanted, I could throw an average total cost and average variable cost as well. But for now, let's keep things simple. Okay. So what's my optimal output going to be? Your first impulse might be to say, my optimal output should be where price equals marginal cost, right? This is what we've done all along. It seems fairly simple, fairly obvious, right? If my price equals marginal cost, it means that I've sold every unit that cost me less to produce than the price, right? I haven't sold any units that cost me more to produce than the price. So clearly, this is the best I can do, right? Just like it would be for a competitive firm. So I'm going to argue that this can't be the case. We're never going to produce where price equals marginal cost if we're a monopolist, or if we have market power. The reason for this is, if we think about this very, very last unit we sell, right? I'll say QA. This very, very last unit we sell, we're selling at a price that is exactly equal to marginal cost, meaning I'm earning no profit on that unit, right? I'm just as well off making that unit as not making that unit. And that's fine, right, when we don't have control over a price, because if I'm earning 0 profit on that unit, I'm earning a tiny bit of profit on the unit before, what the heck, right, I'll go for it. But in this case, I'm actually giving up a really important thing by producing that last unit. What I'm giving up is that I have to sell every other unit that I'm producing for a lower price in order to attract a customer to buy unit QA. Right? In other words, if I produced a little bit less, I could have produced what I'll call price 2 instead of a price 1. I would have made more money on every other unit that I produced. So effectively what this is saying is, when I'm choosing how much to produce, when I have control over the price, there's really 2 costs to producing an extra unit. Right? The first, as always, is just our marginal cost. Right? It actually takes resources to make that unit. But the other cost is that I have to charge a lower price on all existing output. Right? And as a result, right, once my marginal cost is equal to the price, I know that I've made too many units, right? Because I'm going to have a difference between marginal cost and price in order to justify the lower cost on all existing output, right? So I'm actually going to want to produce somewhere like B and charge a price that's higher than my marginal cost, right? To justify the fact, to account for the fact that making more output forces me to lower my prices. Okay, so this is a nice little conceptual argument, right, for why we shouldn't produce where marginal cost equals price. But it doesn't tell us exactly how much we ought to produce. So to do that, let's formalize this a little bit. Let's think about this mathematically. So we know that our profit is going to be our price times our quantity, right, our total revenue, minus our cost of producing Q units of output, right? When I couldn't control the price, when the price was just a number, I basically said maximize profit when price equals marginal cost. Right? The reason for this is the price was my change in revenue when I changed my output. Now that I have market power though, what I'm going to say is I'm going to maximize profit when what I'll call marginal revenue, right, the extra revenue that I get for each unit equals marginal cost. And my marginal revenue, the change in revenue from producing an extra unit, is no longer just going to be the price of the unit I'm selling. It's also going to be the change in the amount that I can charge for all my other units. Right? So what's marginal revenue? Marginal revenue is going to be the derivative with respect to Q of P of Q times Q. Right? The change in my total revenue that comes about from changing my output. What's this going to be? Well, this is just a chain rule problem, right? We've got the derivative of P of Q times Q is going to be P of Q times the derivative of Q, which is just P of Q, plus, right, the derivative of P of Q times Q. So plus Q times dP of Q dQ. Does this make sense? So what am I saying here? I'm saying that the revenue I get from producing an extra unit has 2 pieces. Right? The first part is that I get the price that I charge for that unit, right? P of Q. But the other part is I had to lower the price of all my other units of output. What's the consequence of that for me? It's that I lose revenue equal to the change I have, the amount that I have to lower my price to sell an extra unit, times the number of units I was already selling. Right? So the bigger the change in price has to be in order to sell an extra unit, the bigger this component's going to be. The more units I'm already selling, the bigger this component's going to be. Right? So this piece here, right, Q times dP dQ, is exactly this. Right? The fact that I have to lower my prices on all existing units of output. So what's my marginal revenue curve going to look like? Well, it's going to start at the same place as my demand curve. Right? When I'm selling no output at all, this second piece here, right, Q times dP dQ, is going to equal 0. My marginal revenue is just going to be my price. Right? Because I'm not losing revenue on any existing units. As I produce more and more and more output, the difference between marginal revenue and price gets bigger and bigger and bigger, right? Which is another way of saying that my marginal revenue curve has to be steeper than my price curve, right? So my marginal revenue curve is going to be steeper than my price. Looks something like this, right? And I'm going to produce where marginal cost equals marginal revenue. Right? That's going to be my monopolist's optimal output. Why is this optimal? Because this is maximizing total profits, right? It's maximizing the difference between my revenues and my costs. If I produced another unit of output, my increase in revenue would be smaller than my increase in cost, so I'd be losing money. If I produced a little less output, right, then I would be losing the chance to make a unit of output where I would get more revenue than I increase my costs. Awesome. How much am I going to charge for this unit of output? Am I going to charge here? No, right? I'm not going to charge where price equals marginal cost. I'm going to charge as much as I possibly can for the output that I produced, right? As much as I possibly can for Q star units of output. What's the most I can charge? Well, I'm going to find that out by going to my demand curve, right? Or my inverse demand curve. I'm going to find that out by saying, well, what's the most I can charge for Q units of output? Which is going to be here, P star. Okay, wonderful. So this is what we're going to do, right? And this is why it's going to make sense. Let's go through an example to see how this works in practice. So let's start out with a really simple example, or an example that is going to be similar to what you might have already seen in 101 and 102. So we can imagine that our cost for Q units of output, right, for Q mop socks is 1/2 Q squared. And let's imagine that our demand for mop socks is given by QD, or QP, is equal to 100 minus 1/2 times P. Right, so a nice linear demand function. Okay, great. So what do we need in order to figure out the profit maximizing price and quantity of mop socks to sell? Well, the first thing we need, right, is we need to know our marginal cost, right? We need to know how much each additional mop sock costs us. So we'll just find our marginal cost in terms of Q is dC to Q, right? So this is going to be Q. Right? In other words, I've got a marginal cost curve like this. Right? The slope of 1. Great. What else do I need? Well, I'm going to want to know what price I can charge for any given number of mop socks that I produce. Right? So my demand curve tells me how many mop socks consumers are going to buy at a given price. I'm going to want to invert this so that as a firm, I know essentially how my decision about how much output to produce affects the price I'm able to charge. Right, so I'm just going to solve for P here. So I'll say 1/2 P equals 100 minus Q. Right, P is going to equal 200 minus 2Q. Notice here, by the way, because we now have this one firm, I'm being a little bit sloppy with the capital and lowercase q's, because these really have the same meaning, right? Industry quantity and firm quantity are exactly the same thing. Okay, great. So the price I can charge is 200 minus 2Q, right? So it's a downward sloping line that goes from 200 to 100, something like this, right? P of Q equals 200 minus 2Q. Wonderful. And then what else do I need to know? Well, I know my price, I know my marginal cost, but what I need to find out is my marginal revenue, right? In other words, I need to know how much additional revenue I get from each unit, taking into account the fact that each time I produce an extra unit, I have to lower my price, right? So my marginal revenue of Q is going to be the price plus Q times the change in price from a change in quantity, right? So P of Q is 200 minus 2Q. What's the P to Q? Well, the derivative of price with respect to Q is going to be negative 2, right? So minus Q times, or plus Q times negative 2. Right, in other words, my marginal revenue equals 200 minus 4Q. Right, so this is probably what you were expecting if you remember this from the intro courses. Right, my marginal revenue has double the slope and the same vertical intercept as does my price. The reason that this is true is because of the fact that the derivative of my price with respect to Q is in this case -2. Right? But this rule, my marginal revenue is P of Q times Q dP to Q, is going to hold regardless of the functional form of my inverse demand function, right? It's not just going to work for linear demand functions. Great. So I'm going to have a marginal revenue that's double the slope, right? Has a slope of -4. We'll have an intercept of 50 here, and this is going to be MR Q equals 200 minus 4Q, right? How do I choose my optimal output? I'm going to choose optimal output where marginal cost equals marginal revenue. Right? Find Q star. Marginal cost equals marginal revenue. So that's going to give me Q equals 200 minus 4Q. Right? 5Q equals 200. Q is going to equal 40. Right? And what's my optimal price? I'm going to plug this back into my inverse demand function, right? So it's going to be 200 minus 2 times 40. So my optimal price is going to be 120. Right? And make 40 units of output. I'm going to charge 120 bucks for each unit. So my profit maximizing price and quantity is going to be right here. Wonderful. Wonderful. So now we know how to find our optimal price and quantity as a firm with market power, given, right, a demand function and given a cost function. And what we found, right, as we've talked about, one of the really important properties here is going to be that my price is higher than my marginal cost. In other words, right, when you buy a product from someone with market power, right, whether that's Apple or Kumquat Coffee, some of what you're paying for is the cost of actually making the output. But another part of what you're paying for is the firm's markup. We might want to understand how the amount of that markup is going to be determined by the firm's demand curve. Right? We generally expect that as demand is increased, firms are going to charge more and are going to produce more. But we might want to think about how does the shape of this demand curve determine the firm's markup? And in turn, that's going to tell us, are we producing 40 units of output at a price of 120, regardless of the shape of the demand curve? Or does it matter how much we could charge for 35 units or how much we could charge for 45 units? Right, so we're going to call this here the markup. This is important for a couple reasons. The first reason is, from an economic theory perspective, we really hung our hats on the idea that price equals marginal cost. Right? This was what gave us efficient output efficiency. Right? As we said that when price of a good equals the marginal cost, then the ratio of two prices is going to equal the marginal rate of transformation. Right? The amount of one good you have to give up for another good, which is going to equal the marginal rate of substitution. Right? So the farther we deviate from that, the farther our price is from our marginal cost, the farther we're going to get from output efficiency. The other reason is, this is one of the few times in this class I can give you an immediately practical and useful piece of advice. Right? If you can find out how much of a markup you ought to charge on different products, that gives you a really useful tool for deciding whether a particular product is overpriced or underpriced. Cool. Okay, so to do this, why don't we first of all define our markup, just as price minus marginal cost, right? Just like it is on the graph. Then I'm going to notice that my marginal cost equals my marginal revenue, right? So I can say price minus marginal cost equals price minus marginal revenue. So far, so good. And what's my marginal revenue? My marginal revenue is price plus Q times dP dQ. Right? As we just found out. So this means the prices cancel out, and I'll say price minus marginal cost equals negative Q dP dQ. Now this is the dollar value of my markup, but it might make more sense to think about my markup as a proportion of my total price. Right? In other words, when you buy a cup of kumquat coffee, how much of your $4 is paying for the cost of producing that coffee? How much is paying the firm's markup? Right? When you buy an Apple computer, how much is the price of producing the computer? How much is the firm's markup? So I'm going to divide both sides by P. So I can say how much is the markup, how much of the price is markup, right? What percentage of the price is markup? So give me negative Q over P times dP dQ. So from here, this is starting to look somewhat familiar. This looks a little bit like an elasticity. And that might not be really clear to you right now. So I'm going to restructure this a little bit. Just going to make this negative dP dQ, dP over P, times Q dQ. Right? So dP over P is the change in price as a percentage of price, right? Percent change in price. This is 1 over the percent change in quantity. So I'll make that clearer by saying negative dP over P over Q over Q. Percent change in price over the percent change in quantity. Now my elasticity of demand is just the inverse of this, right? It's the percent change in quantity over the percent change in price. So this is just going to equal negative 1 over the elasticity of demand. Right? Or actually, I think we define the elasticity of demand as the negative. So we'll just say 1 over elasticity. Right? In other words, my markup is going to be the inverse of the percent change in price that comes from a percent, I'm sorry, the inverse of the percent change in quantity that comes from a percent change in price. So let's think about what this is telling us. If we had an elasticity of demand of infinity, right, which is the case for a perfectly competitive firm, right, what that means is if I increase my price at all, right, from the market price, I can't sell anything. Our markup would be 1 over infinity, which is 0, right? We charge no markup, which is exactly what we find for a competitive firm, right? They produce where price equals marginal cost. As my elasticity of demand gets smaller, though, right, my markup is going to get larger and larger. So if I had a firm that was almost perfectly competitive, right? I had a very slightly downward sloping demand curve. I would end up with a pretty small gap between my price and my marginal cost. Right? If I had a firm that had very, very inelastic demand, that gap gets bigger and bigger and bigger. And as my elasticity of demand gets closer and closer to 1, this gap becomes 100%. Right? If I had an elasticity of demand of 1, then what that would tell me is I would produce where marginal cost equals 0. Right? Where 100% of my price is a markup. So for example, right, if I'm a software company, that might be what I do. Right? Selling an extra unit of Microsoft, right? The production cost is effectively 0. Right? So I'm going to charge just where price, right, I'm going to charge where my marginal cost is 0. Right? What this means in practice is that any firm with market power is always going to choose some price where it has an elasticity that is greater than 1, or at least no less than 1. And the reason, right, if you had an elasticity that was less than 1, then increasing your price by 10% would reduce the quantity sold by less than 10%, so you would increase your revenue, right? You could always have more revenue by reducing the amount of output. In other words, your marginal revenue would be negative. Another important consequence of this is that it means that it's not enough, if I want to know how much a firm ought to produce, it's not enough to know how much that firm would sell at a particular price. If I was still able to sell 120 units, if I was still able to sell 40 units at a price of 120, but my demand became less elastic, what this suggests, my demand became more elastic, what this suggests is that I would increase the amount that I produce and decrease the price. Effectively because, right, my marginal revenue would become flatter as well. And so the point where marginal revenue equals marginal cost would be at a higher level of output. Right, so it's not enough to know that I could sell 40 units at a price of 120. I also need to know how much more I could sell by reducing my price, how much more I could charge by reducing the amount that I sell.